Hello everybody, and thank you for joining us for today's presentation of PIKE Electronics Advanced Manufacturing Framework, or AMF. What I want to do today is show you how the Advanced Manufacturing Framework can help manufacturing companies save time in the production cycle, all the way from order entry to order delivery. It is a combination of 20 years of manufacturing vertical know-how that PIKE Electronics has accumulated over the past 2 decades, and a decade of TIBCO integration know-how. And we believe that we can take you all the way from global order entry down to the lowest production level and all the way up to order delivery and show you and visualize the order all the way through the process. With this we can save you time, money, and increase your efficiency. I now want to show you a high-level architecture, how the AMF works, and what benefits you can derive from it. And now I want to talk to you about how today's manufacturing enterprise look. I'm going to draw today's architecture, how we've seen it over the last 20 years evolve, and the problems we see today. Now I'm finishing up drawing the last business level system, which is the customer relationship management system. And now if we take a look, we can slowly start to identify a typical manufacturing process and also company layout within one plant. There are several layers to this plant. All the way down in the production level we have the PLC, SCADA, OPC, GE, FANUC systems. Then we have the technological process control, manufacturing execution systems, all the way up to the business level. There are more levels that I could draw, but I really want to focus our split today on 2 main levels that we're going to look at. One is the business level, and the other one is the production control level. And now that I've finished drawing the architecture of how we see today's manufacturing enterprises, I now want to start looking at some of the limitations that have occurred over the past couple decades. The one that we see is a lot of spaghetti connections. And the way this usually looks is that business level as well as production level systems are connected separately. So the CRM mostly talks to ERP and SCM, the SCM talks to the ERP, and the ERP talks to SCM. And then we really see that the ERP, a supply chain management system, really have point-to-point data interchange to the manufacturing execution system and the technological process control, which then talk to the OPC, the SCADA, and the PLC, and back to the MES. If this is not complicated enough, we also usually in today's world have other manufacturing plants that are adding to our orders. So not only one plant fills a customer's order, but many plants in different regions. So if we add additional suppliers, like we have plant 1, plant 2, and connect these as well, we really get heavy spaghetti connections, and our ERP and supply chain management system have trouble keeping up. So now that we've connected all the spaghetti connections from the even third-party suppliers, like we have plant 1 and plant 2, we're now going to look at what happens when orders come in and the problems we face. When an order comes in, a lot of times companies have problems matching the right order or knowing where the order is in the production cycle. So not only can we integrate it, but also show the company where it is. And what we usually see happening is when order volume goes down, we have a common problem that we face is that when orders go up, which is a good thing, even though our production capacity is not yet fulfilled, we see profit going down a lot of times after a certain point. And the reason being is that even though our production capacity is not fully met yet, our inefficiencies in the spaghetti connections make it really hard to scale. And so if the volume of orders hits a certain point, our scalability doesn't follow it. And the order processing takes longer and longer and becomes less and less inefficient. And so what happens is profit starts going down because our general and administrative costs and inventories start going up. What we also find is that information silos are created within certain systems. And so if we take it the production cycle, and we look at how the production cycle stands today and some of the challenges that we face, we have one, inflexibility lack of being able to respond to market demands, and not being able to scale. So we'll sum that up as flexibility. And that actually increases the time it takes to produce an order, so our production cycle. And also what we find is, due to the spaghetti connections, there are certain information silos that are created. So if I take a look at the CRM system, and Tom, with an account executive, wants to talk to customer A, and he needs to find out where his order is, Tom usually can't find out in which state the order is, especially if it's processed by different plants. So Tom needs to call Fred in plant 2 and Jason in plant 1 to understand in which status the order is. And it becomes really manual. Customers get upset. If an order is delayed, the supply chain management system might not know in time. So we also have the silos that are created increasing our production cycle time and increasing our costs and inventories. Last but not least, I also want to talk about the support and maintenance. We have different vendor systems in different plants, systems that have been implemented by hardware vendors, and also custom systems that have been built to accommodate for growth and specific communication needs that you have. And what happens when we have that is that the IT department gets very large, and that also we can't focus on the efficiency of the production cycle. We have a very high support and maintenance cost. And so we have maintenance also taking away from the production cycle time and increasing the time it fulfills an order. And now that we've taken a look at the last factor, support and maintenance, I want to take a trip through our production cycle and see how it responds when an order enters from the customer today. So we have an order coming in, and this purchase order gets processed by the ERP system and sent down into the production level. And what happens here is that our information silos that we have in the different plants and among the different systems process this order disparately. They only know their part of the job. And Todd, the account executive that is taking care of our customer, does not know in what state the order is. And so if the customer has questions, Todd needs to manually call these different plants or different systems to find out what is happening with the customer's order. And Todd does not know in what state the order is until the order is completely finished and ready to be shipped to the customer. And so does the supply chain management system. And if something happens due to our inflexibility and information silos, the supply chain management system might be out of sync. Or Todd might tell the customer something differently from when the actual order is getting delivered. So now that I've taken you through a complete order process, how it is today, and the different factors that we have, I now want to talk about what we can do to get rid of this process. So I'm going to start by eliminating all these spaghetti connections and talk about the first piece of the puzzle called TIBCO's integration. Now we can start looking at what TIBCO can do to integrate the cycle. And the first key is that I've eliminated the barrier between the business and production level. And the reason is that TIBCO, due to its agnostic architecture, can leverage both the business and the production level and integrate on both levels and bring the messaging that was before very disparate and point to point into a common layer and common level. We can integrate all business level systems, which is adapters that TIBCO already has and provides to over 4,000 customers, with the production level system, which we can do because of PIKE's 20-year manufacturing know-how. And we have built custom adapters to be able to integrate into the technological process control level, as well as into the low level of machine interfaces, such as the OPCs and the SCADAs. And we're also able to integrate all third-party suppliers. What this allows us to do is be able to have real-time messaging through TIBCO integration on one standardized platform, and all systems and all applications communicating with one another in real time. That we've implemented our standardized messaging platform and brought the production and business level communication on the same layer, we now can talk about what happens when a